Kennedy. Bill Kennedy is one of the authors of Go in Action, pretty much all-round superstar when it comes to Go, and a thoroughly interesting person, one of my favorite presenters, and like what this guy doesn't know isn't worth knowing. So really looking forward to this talk. Bill, please, over to you, man, and thank you so much.
Hey, everybody. Thanks for giving me a half an hour of your time today. I'm really excited to be here. So it is my understanding that everyone in this room is pretty much a gopher, right? Day in, day out. You guys have a lot of experience writing code in Go. So what I thought I'd do today is talk more around package-oriented design, some thoughts and ideas that I've been trying to put together for the last few years on different projects. You may have already experienced this, that a lot of people that are coming to Go can quickly pick up the language, but when it comes to trying to figure out how to organize that project you're working on, especially for longevity, it gets really confusing. Because you've all been trained really to kind of think about code and organize code in an object-oriented way, or to just organize the code that you want in whatever folders that you have there in your source tree. And Go has kind of fundamentally changed the way we think about organizing our code, putting our code together. And so I think this is one of the biggest problems that I see as people come to Go and start to work on big projects. I've seen some really interesting quotes lately from a couple of giants in our industry who've been coding since the 60s, and they all kind of start to refer to legacy code as either the downfall of mankind, because there's going to be so much of it, nobody wants to maintain it, or just recently, last night on the plane, I can't remember his name. He's one of the inventors of awk. He basically said projects fall into two categories. Either they fail or they become legacy horrors. But what I'm finding from a Go perspective is that your first version of your projects are starting to turn into a horror because, again, around packaging and not being able to organize our code the right way the first time. So let's jump into some of the thoughts that I have around this. I do have a deck that I'll share with you. It's a deck that I used in India. It hasn't really been released yet, so no one's really seen it. Let me share that with you. I won't be able to see you when I talk, which is always a shame, but I'll try to go through this deck quickly so you can get a sense of where I'm coming from. So let me share that. You guys can see that. Let me know if you can still see it if I play this thing, because I'm not really good with slide decks, and not that I can even remember how to play it. Can you still see the deck?
Yeah.
Okay, perfect. Okay. I really believe that if you're going to learn something, and then especially if you're going to teach something, I think everything has to kind of fall into a history, so you can have a perspective of where we're coming from. Then some mechanic.
Oh, sorry.
You guys can
lost the slide deck.
Can you see it now?
Yes.
Yeah. I'm just going to leave it like that if it's okay with you guys.
Yeah, of course. That's perfect, man.
Wrong way, isn't it? All right. I'll leave it like that if that's okay. So I really believe that you need a history and a background for the things you're doing. It's really great to have mechanics around how things work, and then we can kind of get into design. About a year or so ago, I was reading an interview that this person, who's really he's done amazing things in industry too. I didn't realize it until I really looked him up. But he gave an interview to Brian Kernighan, and he asked this question. What can you tell us about the worst features of C from your point of view? And the answer that he gave was pretty astounding to me. Now, this interview was back in the year 2000. And there's a lot here. I'm sure you're trying to read it now, which is fine, so I'm not going to read it. But the answer for me, his answer kind of gets broken up into three really important parts that I now focus all my training around, really, right from the beginning. And it's these three things right here. he's saying that C really was missing this idea of creating these firewalls within the programs. And it wasn't that you couldn't simulate like this stuff, like you can do in object-oriented programming. It's just that the language really wasn't there providing any support. And when I read this about what he felt was a flaw in C, that you couldn't really keep the various pieces of the program apart, and that really limited large teams to be able to work on large projects. And the key here, that the compiler and the language itself wasn't providing support. I mean, I fell out of my seat, because this is exactly where packaging is coming from. It's giving us the ability to create these firewalls that the compiler, that the language can help provide support. And so with this background, now it gets interesting, and you want to say, okay, great. So here's the problem we're trying to solve, but how does the language provide this support? And this is kind of where we get into the mechanics. And so here are some core things, I think, from a language mechanics point of view that Go is doing as it relates to packaging. Now, as I've said already, I really believe packaging directly conflicts with how we've been taught to organize source code with other languages. We can no longer just create a source tree of folders and put code in it, because one of the things that Go is doing, as we all know, is saying that every folder represents a package. It is that firewall that Brian's talking about. And underneath the covers, it really ends up being a static binary, right? It's a static library that we cannot choose to ignore. Because you could say, well, other languages like C, I can create all the static and shared libraries that I want. Yeah, you can. And you could build your entire solution around that static library. But it's a choice that you get to make. In Go, it's not a choice. Every folder is going to be that static library. And so you're thrusted into this world that we really haven't lived in before. But what's really interesting is when you look at your source tree, you can almost think of every folder as this microservice associated with the entire project. Where before, what we were really building from a source tree was a monolithic application. Go is kind of throwing this idea of microservices at us all the way into the source tree itself. And I think one thing that happens to us as well is that we forget that there are no sub packages in Go, that everything is first class, because everything gets built as a static library, flattened out at the end of the last piece of when we're building. And so if there is any sort of concept of sub packages, it's really our own concept. It's not part of the language itself. And now that we say, well, a package is this standalone API, it's the things that are firewalled. We need those aspects of that package that need to be exposed or open. We can use that terminology from a firewall perspective. And that's where we get into that exporting and unexporting. Again, we're talking about language mechanics, right? So it gets really interesting here. If we just step back and say, okay, Brian, what was wrong with C? Well, the language didn't give us support to package things in a way that the compiler language can help herself. And Go says, okay, we can do that. We'll do it at the folder level. We'll create these static libraries. We'll give you the ability to export things out of your firewalled package. We'll try to keep dependencies and code reasonable, right? Packages can't cross-import each other. There's lots of reasons for that. But I think one of the big reasons, or one of the big advantages of this idea that packages can't import each other, is it really stops to make you think about what you're doing in terms of packages. And this is one of the big things around package-oriented design, as I'll get there, that I think is a big benefit of it. It's let's slow the team down just a little bit so we can have conversations about what should be a package, where should that package be, what does that dependency tree look like, and we can just make better decisions. So from a language mechanics, we probably all knew this. I'm not telling you anything that's too new, but we've got this background. And now with the mechanics in place, I always love to talk about design philosophies. I really hate patterns. I don't hate frameworks so much. I think you need to build frameworks, but to just take a framework off the shelf sometimes is no different than just picking a pattern off the shelf and then trying to apply it to everything you're doing. And so it's design philosophy that really allows you to, I think, to be a better designer and architecture and software developer because you're thinking about what you're doing. And now, from a design philosophy standpoint, I think there are three things that we want to focus on when it comes to packaging. We want to focus on purpose, we want to focus on usability, and then we want to focus on portability. These are three things that we've got to have answers for and has to be part of all the decisions that we make. So let's focus on purpose first. I've got some little sound bites here kind of to trigger some conversations around this. But I think for a package to be purposeful, it must always be providing and not containing. And so what does that mean? Okay. It means that packages must be named with the intent to describe what it provides. That if you're not able to come up with a name for that package, if you're not able to think about what is this package providing us or providing other projects in the future, we have a problem. You might end up really with a package that contains things, and what happens now is you have a package that just becomes a dumping ground of disparate concerns, and that always feeds into really bad dependency trees later on, which is going to cause your projects to kind of crumble over time when you do want to refactor and change things. So from that purpose perspective, I always want to make sure I should be able to go over to you and ask you, what is this package doing? Why are we building this package? What does it provide? What is its purpose? And it should always be really clear what that is. Now, usability is a really big thing for me. And so from my perspective, from a package to be usable, it must be designed with the user, the application developer as their first focus. I always cringe when I hear people say we have to write code that's testable, where they're putting the test above everything else. And in languages like, say, C# and Java, where you have no choice but to define what contracts or interfaces, concrete types are going to comply with. You have no choice there. And I can understand how we got into this mode where everything has to be testable, and as a first priority. But as we all know, Go has changed the rules on that. Any concrete type in any package can be compliant with any interface in any package at any given time because the compiler does that at compile time. And so I think one of the is we can get out of this mode of saying everything's got to be testable to everything really has to be application developer focused usability. And so this is an obvious one, right? We want to always be striving to minimize, reduce, and simplify everything we're doing. This is a big mantra in Go. It's actually a big mantra if you read a history of developers, the Brian Kernighan's and a whole bunch of other people who've been writing languages since the 60s. They continue to say this over and over and over and over again. And so we just want to make sure that things are intuitive and simple to use, focusing on that application developer, right? We want to be designing with that user as the focus. Okay. Oh, I went the wrong way. Sorry. This is a big one that I see all the time, and it actually bothers me a little bit. I see a lot of packages that extend APIs for the sake of usability to make it simple, but they ignore the impact that those APIs have on resources and performance. And I know that we always want to optimize for correctness first, but there are times where if we don't understand how escape analysis is going to work, if we're writing a function or a method that's going to be in a tight loop, and that function or method is allocating on every call, I mean, that's a real problem. We can write APIs that accept slices, accept the memory to be used in order to minimize resources and performance issues. And so I think there has to be a balance there, and a lot of developers miss it. And here's the big one, right? We got to do things that minimize the cascading changes back up into the user application. Now, this is where interfaces can play a big role. The error interface is a great example of this. I mean, if you really think about it, we do error handling from the perspective of an interface, which if we can maintain all error handling around an interface, then packages can improve the concrete implementations, improve error handling, and they don't cascade back up into the user application. And so, decoupling is a big part of making packages usable. Now, when we talk about interfaces and we talk about decoupling, Go does have the concept of type assertions. And type assertions can be really, really powerful. We could use an interface to deliver a concrete value across a program boundary. But when I see type assertions, I usually just let it raise a flag with me, because we went out of this way to declare an interface, and suddenly we're going back into the concrete. And anytime we're working in the concrete, we're putting ourselves in a situation again where we're walking away from that decoupling. And that could hurt in terms of usability. And so from a usability, again, I think the mantra here is reduce, minimize, and simplify everything you can. You're not going to do that day one. Refactoring is such an important thing. Prototyping and refactoring are key to usability. And unit testing, really, from my perspective, should be used to validate that the API is minimized, simplified, and reduced. And use that unit test not just to validate that things are working as expected, but that the API is clean. Now, the last thing is portability. Portability does go into reusability. And so for a package to be portable, it must be designed with reusability in mind. I like the idea of portability because I like the image of being able to physically pick a package up in my hand and move it somewhere else, just like if I was picking up an apple or picking up a bottle. I love the idea of portability with reusability in mind. And so we really want to aspire for our packages to have the highest level of portability that's reasonable and practical for what they do. The highest level of portability would be a single package that I could pick up and put anywhere in any project, and it would be usable by that project. And portability is going to really depend on what the package is, where it lives, and what its purpose is. Now, in order to obtain those high levels of portability, we need to think about the opinions that a package takes on. An example of this would be a package you're writing. Let's say it's a log package that you want to be usable across many different projects that you're working on. Well, if that log package imported a configuration package that only worked with environmental variables and your project didn't, now you're kind of creating an opinion that configuration happens in a particular way. Or vice versa, you have a package that you want to be really portable, but it logs. And because it logs and it's taken on the opinion of what logging is and the purpose of logging, you've no longer allowed it to be as portable as it could be, because if some application doesn't want to log the way your package logs, it's no longer in play. And so opinions become really important, and knowing when you're allowed to make opinions, when you're allowed to take on opinions, and when you're not, needs to have a discussion around your package. This is when we get back to these ideas of a package containing something, like a package called common or util, because they become a single point of dependency. Every time you want to use the package A, this util package is attached to it and has to move around it. And I think we've all learned over time that dry or a little copy and pasting can go a long way to maintain portability. All right, so I've given you some design philosophies around purpose, usability, and portability, things that I'm not telling you anything probably too new here. We're just laying it out as a way of saying, as a checklist, let's make sure that as we're developing code, that our language mechanics are sound, that our design is sound against these ideas that I think we've learned over the last 40 years are things we want to aspire to. And now we get into what I call package-oriented design. I have developed over the last few years a project structure that promotes communication and promotes the ability to really help design packages with these philosophies in mind, and really helps teams communicate and talk with each other. So for me, package-oriented design does three things. It allows a developer to identify where a package belongs inside of a Go project. We'll define what a Go project is in a second. And based on its location in the project, it sets the guidelines that those packages must respect. There's no more debate. It's we come together, we identify this is where it belongs, so these are the rules or the guidelines against it, and we can have some really healthy conversations around that. It also defines what a project is and how a project is structured. I will show you that. I'm going to show you one potential project structure that I use. I've been using it with a lot of success. It doesn't mean this is the only project structure that you could have ever. And I expect over time that we're going to learn more and come up with others. And finally, this is the key, man. This is the key to everything. If you guys are in a team environment, you know this, right? Just the ability for people to communicate constructively and make the best architectural decisions. Because what we do is not really about the code at the end of the day. It's about design and architecture, making sure we're thinking about these things at every moment of today and for tomorrow. So that legacy code that we're all talking about, right? I don't know if we expect the projects we're working on right now to be around in 5 or 6 years. I definitely have a couple of projects right now that are 5 or 6 years old. And boy, do I want to go in and refactor the hell out of them. But they're solid and they're working, right? And so this idea of being able to promote good design and architecture at least can help you maybe hedge back before you really have to go crazy on a refactoring. So let me share with you the project structures that I have here, and again, that I'm teaching and promoting my clients to use as well. I think every company should have a single Kit project. Now, some companies like to separate the Kit packages into separate repos. I find that to be a management nightmare. But I want you to think of your Kit project as your company's standard library. These are things that all teams should be using. And a lot of times you're going to see log in there and config in there, and maybe some authentication stuff, maybe some database support, things that all projects should be using and having the same opinions on. They go into your Kit project. A project is really a single repo that is managed as a single repo with everything there. Now, application projects are also single repos. And an application project is the sum of all the binaries that we're building, services, CLI tools, background processes that get deployed together as one thing. You could almost call it your platform if you wanted to. But depending on how large your organization is, how many teams you have, you may have multiple application projects. Less is always more. I always stress that. The less repos you're managing, the less projects you're managing, the better things are going to be, because the entire team that's working on that project has the same opinions, moving in the same direction. Nobody can go off. I've been on too many projects where teams are way too isolated, and they're doing logging configuration one way, they're doing logging configuration the other way. And now when it comes time to deploy this thing, it's a mess because there's so many different things that are going on. And so these application projects require that the entire team is moving in the same direction. And the Kit project, when it gets introduced into your application projects, also help that the entire organization is moving in the same direction. So here's a typical Kit project. And for me, these are like packages that I use in all my production or client projects all the time. CFG, log, maybe some pooling if you need it. Now, again, if you're more comfortable putting each of these packages in their own repo, go for it. I'm not going to stop you. I mean, I tried that early on, and the management nightmare was over the top for me. So because also we're going to be vendoring these packages inside of application projects, what's nice is that the tooling like Go Vendor, which is the one I use, lets you cherry pick these packages out of the repo. You don't have to vendor the entire repo. And so it's another reason why I think on a management side, it can be more effective to keep all of these packages together. Once you've really established these packages, they don't change that much either. Now, for me, your application projects, for me, my application projects take on this form. Again, it's a single repo, and the repo has at least these 4 folders And these three at the root: command, internal, and vendor. And then there's a platform folder inside of internal. So let's just briefly talk about what these folders do. Vendor, I think, is obvious. We're going to be vendoring our third-party dependencies that this project has decided that they're going to take on. Your kit packages would be vendored in there as well. I use GoVendor. There's some great tools out there like Glide and GVT. And the community is really working hard. Maybe in 1.9, there may be some new things around vendoring dependency management that we get that might change some things here. But for now, I always teach to keep a single vendor folder. Try not to have vendor folders inside of vendor folders. That is something they're looking at trying to allow to happen just because of the scale that Google's at. But if you can really flatten out your dependencies here, it really simplifies things quite a bit. I showed you this. This is what I wanted to show you now. So here's command. Now, what command is going to hold is all of the binaries that you're building. You can see here I have a folder, or technically it would be a package because there's a source code file in there called Servy. One is called Servyd. I use that D naming convention to denote those daemons that I'm building, are like the web services, things like that. And if there's no D, you can assume that's a CLI tool or maybe some sort of background process. And there's a servy.go and servy, a servyd.go. That's where your main package is. And then you've got other packages that you've got included inside of these. And one of the things you have to understand is that these packages that you're adding here are very specific to this binary, that they're not reusable across the project. They're not reusable across multiple projects, that this package here is providing something very specific to building this binary. And most of the code here is really going to be for startup and shutdown configuration. Maybe your handlers get configured here, routes, things like that. Very, very application specific. Internal is where things get really interesting. Now, there's a couple of things here as it relates to internal. Compiler respects the word internal as a folder name. In other words, no other repo or no other package in any other repo can import any package inside of internal. The compiler will not allow it. It is why I really love this name, because it's not only denoting that these packages are internal to this project, but the compiler is also giving you help. Now, I've got lots of rules for these types of packages, and I've got 2 blog posts on goandgo.net that lay everything out that I'm showing you in great detail, so I won't do it here. If you're really interested, read those blog posts. They go into great detail. But here are a few of the things that, at a high level, that I'm looking at here. Internal packages are packages that are reusable across the project for building commands. Commands that need the attachments package or the orders package. And that's why they're here. If there really isn't reusability across the project binaries, most likely that package belongs under command. Now, I've got lots of little rules here to maintain levels of portability. One is the 2 packages at the same level, so say attachments and orders, they are not allowed to import each other. If you attempt to do an import across 2 packages inside of internal that are at the same level, that is a big warning flag. Now, your first thing might be, Bill, what if there are types in orders that attachments needs? Look, at that point, if they're at the same level, it's a definite big smell if you're doing an import because you want access to types. Types are an artifact of the greater API. In those cases, I would say, maybe you need a package that imports these 2 packages, and maybe that package belongs in command because you're doing something specific. Or maybe, like in the relationship you see here between customers and orders, maybe that package belongs under another package. So in this case, customers, items, and tags are not allowed to import each other, but orders is allowed to import those and nothing else inside of internal. We're using the source tree to show dependency relationships and making sure that the levels of decoupling that we want are there and they're visible, readable, just by looking at the source tree. So orders can call into customers that can perform that import. It could create a higher level set of APIs around that. But attachments and orders definitely couldn't. Now, CMD, which is command, the command side, it has really no restrictions around what it can import outside of the fact that packages inside of Serv-E could never import packages inside of Serv-ED. So there's a restriction there. There's still the same level package imports. These packages really should not be importing each other. If routes needed handlers, handlers should be inside of routes. You want to maintain that relationship at all times. But command can import anything from internal and can import anything from vendor. Internal cannot import anything from command, but it can import from vendor. Now, I've got a special folder under internal called platform. And I always think of platform kind of like the standard library for the project. These are things that are creating or that are providing foundational things, like maybe extra database support, crypto support. Now, in this case, command can import into this. Anything inside of internal can import into this. I do also relax some rules around imports at the same level, but these platform packages cannot import from command, cannot import into internal. They can access vendor. Again, all of these rules and more are laid out in the blog posts. But I think what you're starting to see here is that we have a project structure that denotes what a package's purpose is, where it belongs, then the rules around what their dependencies are allowed to be around opinions. Like none of these packages here are allowed to log. In fact, from a platform perspective, just like in Kit packages are not allowed to log, platform packages are not allowed to log. Why? Because they really need to remove that level of opinion so they're much more portable. But internal packages can absolutely log if you want them to. They belong to a project. They are taking on those opinions. Command packages, well, I mean, that's as specific to that project as you can get. They can have as many opinions as they want. Again, I've got a lot of these rules laid out, and we really promote some excellent design and conversations. And we have found over time that we were building APIs that really were not focused on portability and decoupling because we wanted to share types, because we were just kind of putting things where we felt it made sense, but not really around any guidelines. I'm going to real quick stop that sharing. So the big takeaway here is, I've given you some history, I've given you some mechanics, I've given you some design guidelines, I've given you my thoughts on project structures in Go. I really do recommend to read the goandgo.net last 2 blog posts to get some really detailed information on this. But I think the big thing here is that we don't want our projects to fail. At the same time, we don't want to be working on our projects 5 years from now either, right? We're all in this same kind of legacy boat. And at the same time, we want to make sure, though, that there is longevity in the project. And I think from a Go perspective today, it's this package design that's really hurting us. Now, the one thing that gives me hope is that the language is so small. There's been about this much code written in Go right now. That's it. When we think about Go's lifetime over the next 10 years, this is about how much code's been written. This is about how many mistakes we've made. And so all of us in this room have a responsibility going forward. Everyone in this room is going to be mentors and teachers for the next generation of Go developers. And these aren't going to be academics. These are going to be people that are coming from languages. They just want to solve problems. They want their code, obviously, to run fast, but productivity matters more. And everybody in this room has a responsibility of making sure that the next year of code that's written is better than the last year, and so on and so on. And I think package-oriented design is a great step moving forward because it's just going to make us have to really think about what we're doing when we start thinking about the packages we need. So that's my presentation here. I really hope you guys read the blog posts. If you have any questions or anything, if you decide you want to look at this stuff for your next project and you need questions or answers, just reach out to me. I'm always available. That's it.
No. Computer first. Bill, thank you very, 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 very much. I know you're really, really busy. We all absolutely appreciate your time, and that was fascinating. I'm sure I'm not the only one who learned an absolute bunch there, and there's probably people driving straight over to your blog now to get the inner dirt and to put those things into practice. So thank you again from all of us. I really, really appreciate it. I totally owe you a beer, dude.
Yeah, I can't wait till we're together again so I can grab that beer. So
Yeah,
that would be a good day. All right, guys, thank you for hanging out, and have a great day, and we'll talk soon, Nick.
Thanks, man. Bye-bye.
All right, bye.